We're going to talk a little about modern data systems and how it, in some cases, relates to what we're doing here. So does people know what happens when you open your browser and type in emotion.ai? What's happening is when I access this web page, it's trying to look for the IP address. And does anyone know what an IP address is? What's happening is this website, emotion.ai.org, it actually maps to an IP address. And in the world of the internet, we're very familiar with www.google.com, www.something.com, or .org, whatever. All those addresses actually map to an IP address, which looks kind of like Internet Protocol address. So let's say I'm trying to get Google. Let's see if I can blow this size up. And if I try to ping it, which is a command you can run from your command line interface, you're going to get an address 172.217.036. You can type, what is my IP address? And it'll tell you, in my case, 73.70.11.124. And in some cases, if you're a good hacker, you can just really mess me up. There's a difference between public and private IPs. The public IP is what everyone usually can look up and such. The private IPs are reserved for within your own network. And the only reason why you would use private IPs is that it is not really exposed to the outside internet, extranet world. The reason why you have private IPs is we have a limited number of numbers out there. And you might have heard them going to IP version 6, but at the time they say, well, we want to allocate a certain number of numbers for people that want to run their own network within their that's not exposed to the world. And so I can have my own network and it's reused in another network and it won't conflict. But this mapping, like in the external world, it is mapped to an individual one, like Target is mapped to this. There's no other company can map to this because otherwise it will cause confusion in the internet. So importantly, as others have stated, when I have a URL, it's going to read an IP address and it's going to go find a computer out in the internet somewhere. We've mentioned that we work with the cloud, so a lot of these servers and servers and systems are in the cloud with their IP addresses. And in a lot of cases, these servers or websites have a database that stores data. You cannot run an internet without data. The data will be storing things such as your credit card information, stores things like images, stores information like code. In order for all the internet to work, they need to have a place where all this information is stored. So the server will interact with a database, which is basically where all your data is stored. It will process it in a certain way to provide you, whether, for example, a motion detector by AI Camp or Target or Google or any of the websites that you use in the internet. So a lot of it is, there's a specific type of protocol. When it says protocol, it's a process or behavior that the computers do to interact with each other. If I'm putting in a website, it's making a request to some computer somewhere or a server, and it's providing a response back. So in the case that, I forgot who said this, but it basically renders, if I'm going to a website, it'll render a web page and it'll give the HTML code. And then on my computer, it's reading that HTML code and the web browser will show it as what you see as today. And in the reality of things, when you're interacting online, it's constantly a request to response, request to response. I'm making a request, it's returning a response. And so imagine our whole internet. What we don't see normally is there are tons of servers out there. There are tons of websites out there. There's gazillions of different places where you can go to get information. And that's all supported by a multitude of servers. One, for example, imagine how many people in the world accessing Facebook.com. Last I heard, there's at least 2 billion customers on Facebook that were registered users on Facebook. So it's just like, imagine 2 billion people hitting the system. Imagine 2 billion people hitting your computer. Do you think your computer can handle all of that? No. So what would happen is they need a lot of computers and a lot of computing power to handle that load. And likewise, there's complementary data systems in which to store all the data. Just imagine you store stuff on Facebook. If you use Facebook, I'm storing images, I'm storing my blogs, I'm storing my shout outs, I'm storing my videos. That's just what? Multiply that by 2 billion, at least 2 billion. That's a lot of information that needs to be stored out there. And with regards to databases, imagine database like how many of you actively use Excel or Google Sheets? So this is kind of a analogy. Just imagine a database that has a lot of tables, which is basically a lot of those sheets that you've been interacting with, although it can get more complex, but basically, essentially, they're just lists and rows and columns of data. Other things is when you have the data and when the system's running, the system's constantly creating logs of what's happening. Oh, this person logged into here. Oh, this person uploaded this. Oh, our system just received more information. We're also generating additional data on top of the data that we're uploading to these systems. So just imagine you have 2 billion users that's uploading X times number of data, plus that all the activity that they're doing is being also generated as log information. So we need a lot of computers and a lot of storage space to store all of that. And what's important is they need to be able to talk to each other to make sure that all that data jives with each other. And so imagine that you have a lot of computers out there, a lot of servers, a lot of databases, and then sometimes we need to consolidate all that into a central data warehouse. Basically, what that is a consolidation or a joining of all the information that are on all the different databases out there in the world. Well, depending on the application you want to use. And the reason why we want to put all this information together is, let's say we want to do some analysis on that. So for the example of in machine learning, sometimes we're collecting data. A good example is COVID-19. Let's say Belgium, the countries in Europe, Belgium, France, England, France, they're collecting COVID-19 data. And then in the United States, we're collecting COVID-19 data based on how many people are infected, what is the rate of mortality, or in Asia or in Africa. Every country is collecting data. And let's say we want to do a world analysis on it, we have to collate all that information together, and that ends up into a really big warehouse. And that allows us to really take a look at what's happening around the world, what is the world trend. So if people have ever been to, let's say, how many people are familiar with the Johns Hopkins website that shows the COVID data? So let's go to Johns Hopkins. So they're taking all that data and they're generating it, and they're trying to generate all these information, whether by country, by state. You can even look at it and the trends. They need to put all that data together. And there's a lot of different other websites that also do this. There's a worldmeters.info.com. They're collecting data just similarly to Johns Hopkins and calculating their own information. So why does this relate to us? Well, we're doing object detection, and in order for us to do object detection with neural networks, we need a lot of data. Part of it is we need to go out there and go to different sources to get data. So for example, I heard some groups might be looking for rockfish. So then we need to grab a whole bunch of data on rockfish. Or in the case of our group, we're going to be looking at currency. So we need to be able to pull images of currency from all over the world on specific types of notes. And we'll need to be able to pull all that together and be able to perform the labeling and the cleaning and making sure that we have data to be able to train our model. And so here's a description of, I think this is a diagram of Uber's data systems around 2014, 2015, generation 1. And the key thing to notice is there's a lot of different systems connected to each other. Does anyone know what ETL stands for? ETL stands for extract, transform, and load. And the reason why you'll probably need to remember what this means is because in the scheme of things, what if you imagine, let's say we're Uber and we need images for our project, we're going to have to extract it from different locations. We may have to extract it from Pinterest.com, or we may need to extract it from GoogleImages.com, or we may need to extract it from Bing.com, or there's many different places where you can extract information. Then what we have to do for our project, we need to sometimes transform our information. In some cases, the images we have is not so great, and we might need to clean it up. So we'll need to transform it. And then in the case of our project, once we have all that done, we need to load it somewhere to do the labeling. So in our case, we're using a service called Labelbox. We need to take all our images that we've extracted, clean it up, and upload it to Labelbox so we actually can create our training data and prepare it for the model training. What kind of things can we do with data in general if we're storing it somewhere? So those are basic operations that we constantly do with our databases. We either create it, we either read it, or we can change it or update it, or we can delete it. So this one, I'm not sure I'll make sense in this, but there's two ways of processing data. One way is doing by batch, which we collect a whole bunch of data, and at some point later we process it. So for example, I want to process financial transactions, like how many people deposited money or withdrawn money within a day. Records can be tracked throughout the day. At the end of the day, it could be processed to say, oh, X number of people have done this. So the challenge with that is when we do batches, we can introduce errors into the layers, and the views that we have set up can be changed from the next batch of information that's being processed. So you might have a mismatch between the data that is processed versus the data that is in the process of being processed or it has been changed since they're on.
Richard, can I add a point there?
Yeah.
Okay, so this whole architecture we're about to introduce you is called the Nominal Architecture. Okay, Nominal Architecture. So the kind of problem that Richard just mentioned is like, just say you have so many people visiting a bank, right? Visiting a bank website, and you want to calculate in July how many people visit the bank, but all you have is just a timestamp for people visited. Let's just say you have hundreds of millions of people visiting this bank, then you have to do hundreds of these operations to check each of these timestamps to see if they are like in July or not. So the batch view to do it is basically you say, okay, well, before I do the calculation, I want to prepare this view, which is basically I wanted to give a number for every single day, how many people are in July 1st, how many people in July 2nd, how many people in July 3rd. So then if I want to calculate how many people in July, I only have to add 30 numbers together. See that? It's much simpler than adding maybe hundreds of millions of numbers together, right? So that's batch view, okay? But as Richard's saying, batch view, however, doesn't give you the full picture because you're gonna have data that's in transition, okay? So I guess, Richard right now is gonna give you a view for the complementary one.
So the next one is called speed layer, which is constantly updating over real-time information. So with the real-time, as people are providing information, your information is being updated. But it itself also has challenges in that, so what's happening is, like if I'm doing a search on data, the chances of that error is reduced. So as opposed to batch view, if you're taking from, say, for example, July, then your data in this case is static, but if there are changes to it, you won't get it. But whereas in the real-time view, that information is being updated quickly and constantly. Have any of you heard of a data scientist? If you're a data scientist, one of the key things you're very invested in is data and how it's managed. And if you go, let's say you're a data scientist, you go work for a company, one of the first questions you need to ask is, how does your company manage the data? How do they organize it? And it's very important because it could mean whether you're going to have a great time or a very lousy time at that company. If you go to a company and the data is poorly managed and it's not organized, and if you just simply ask yourself, if you're starting to think like, oh, where is this data? Then you're in big trouble. It basically means that the data is poorly managed. And during this course, while we're going through gathering data and trying to organize data for training, if we ever ask ourselves, where is the data that we gathered? Then we got to like think about how we're organizing the data, or it can lead to a lot of challenges down the road. So importantly, a great company will have their data managed to the point where I can just pull it and use it. And for us, we're not going to be perfect, but it's important that when we get our data, we have to think about how we organize our data. How do we keep track of our data so that when we need to go back and find it, we shouldn't be asking the question, where is our data?
You know, when I was head of data for this company called Blend Labs, this section here is coming from a book. I think the book is called The Big Data Systems. And this whole book is a required reading for us because without understand this, you won't be able to create good data infrastructure, and therefore people are not going to use data, and then as a result, the whole company is not data driven, and as a result, we don't know what the hell is going on, right? So company without data, it's like a deer on a highway. You're lost. You don't know where you're going. You will get into accidents. Just like, for example, if you go and choose your career without data, you'll be lost. You'll be confused.
We're going to talk about ways of getting data. So for our projects, there are different ways of getting data, and your respective project teams, you may have talked about it, but here are the general ways. One is you can get data through using APIs, or does anyone know what an API is or what it stands for? And in our today's internet, every system's pretty much connecting using APIs. So in this particular summer camp, we will leverage APIs to grab the data that we need. There's other things you can also use, such as crawling the web. There's a particular program called Beautiful Soup that you can use. You could also try querying a database. We talked about database earlier. In some cases, some databases are Postgres. There's Influx. There are other types of databases out there. We're probably not going to be using too much of querying a database because our projects are related around images. And finally, there's one final way of getting data, such as loading from a local file. So for example, we might be able to pull a data off the internet, like it could be a spreadsheet or a CSV file. And we just need to load the data using, in this case, Python to load it into our program. So this is a pretty nice website. It actually talks about COVID-19 data, and you can actually grab information by getting a request. And remember we said earlier that we're doing requesting and responses. And some websites actually define how you can get the information as well as what kind of data returns. And can people tell me what format this is? A lot of the APIs we're pulling are going to be, and obviously it's a JSON string coming across, but most importantly, the formatting will pretty much be in the dictionary format. So I believe all of our groups have gone through the Python with Revolve's dictionary and how you can access it and how you can read it a little bit, and we'll talk more about dictionaries tomorrow.
Guys, like API is actually something really, really important when you think about every single app you use, okay? Every single app you use, whether it's like Facebook, Twitter, Uber, right? I don't even know what kind of apps you guys using, but what actually power the apps, they're APIs, right? It's literally your phone is like, okay, I need to sign in. Here's the login and password, right? Sent to the backend. And the backend is like, okay, everything's correct. Here you go. I'm going to give you a token. So you have that token. And then you have that token. And every time when you need to request data from the database, through the API, you send that token together, right? That's how you get authenticated. You see that? So almost everything, okay? I mean, yeah, the entire app store is probably powered by APIs. which you probably never heard, but they're powered by APIs. API can be built using various different languages. So it can be a Python, backend that serve this. You guys heard about JavaScript, right? So it can be also, done by JavaScript, right? So, for example, in JavaScript, you can define, the way you think about it, it's almost like, like this request and response format. That is, if I go visit google.com, I'm basically requesting Google for information, right? I'm getting information, and the Google gives something back. That's request and response, right? So the way to think about it, it's almost like you want to treat an API just like a function, right? We're going to talk about function a lot more, but it's literally like you take this request, the parameter. Oh, what page do you want? Oh, you want the front page? Here we go, HTML. You return the HTML to the user, right? That's the request and response, okay? And API is literally, as I said, is powering the internet right now. At least it's powering the App Store and as well as Android. So, the more that we know about this, the better.